Hejsan och välkomna till dagens webbinar. Idag ska vi snacka om modellering och dokumentation av prefabricerade i Revit. Och presentationen och allting sånt kommer hållas av Valensas som är produktexpert. Så egentligen kan jag lämna ord och bild till Valensas direkt. För han kommer köra några snabba bilder från en PowerPoint och sedan kommer jag köra en live-demo. Så, over to you, Valensas.
Okay, so I can start from here now.
Yes.
You see the slides, and Roger already introduced us. And today we will talk about how to model precast elements in Revit. And in this webinar I will show you how to quickly insert connections into your precast project. So I will demonstrate two tools, two solutions: insert elements and smart details. Then I will switch to Hollow Coast Labs tool, the smart floors. So it's a different way how to model precast floors. And then another good tool to sort elements, to write mark values to different elements according to the rules. And the last tool with smart assemblies is how to prepare shop drawings of your precast elements. Okay, so these are insert element and smart details. I used to insert details to your model. I will just quickly run through these slides because you'll find them in the handouts. You can download them and see descriptions here of the features and tools descriptions. So I will just run through tools, the smart floors, the insert details, then sort mark to sort elements, and how to prepare shop drawings like this with smart assemblies tool. Okay, so now we get to this part, the live demo, and I will switch to my Revit file, and you see this tool for BIM doc and the insert elements tool selected. So I will demonstrate how does it work. So first of all, I would like to insert few foundations here. So I will use this tool. So I select few columns and I select a command to insert elements by related objects. Okay, now from the project tree here, I will find any type of my foundations and I will add it here. And I have a rule to insert foundations related to the column base point. I can set elevation here and click on insert, and all the elements will be inserted under my columns. So I can do this to any amount of my elements. Let's say I'll add some more foundations here. So I will select other columns and I will select again insert elements tool, select foundations, let's say different kind of foundation, and insert again the same way. So I have some foundations inserted. Now I would like to insert connection details. So for this I will select some beams from this model. I will filter structural framing girdle elements, and you will see this beam selected, and I will again insert some details to my beams. So again I go to insert tab, I select this time to insert structural connections, and now I have let's say this connection detail. I will add it here, and now I have few rules how to insert elements. So for this detail I will select to insert at the end and start faces of the beam, and yeah, I will just click on insert, and you see I have inserted 124 elements. Let me see, I'll switch maybe to the shaded mode, and you can see now that these details are inserted at the end point of all of the beams. Of course you will maybe use different sizes of elements to different beams, but I just want to show you the principle, how does it work. Okay, so I have connections for the beams. Now I will insert connections to the columns. So I will select again filter columns this time, and let's say now I will insert other elements. Again, structural column connections category, and I have this kind of connection, so it's for column shoes. I will add it here, and I will select it to insert it to the bottom of my column. So I'll click on insert to model. You can see them added here, but I will also now choose to insert balls to the top face of my column. Okay, and again 68 elements inserted. Okay, well, maybe I need to connect beams with my column, so I will insert additional detail, but now I will choose the rule to place the connection on the side face of the column, but on the face where the beams are connected to the column. So it finds the intersection with the beams and inserts these details in this place. So again, I have more than 100 elements inserted, and now I can see that these details are inserted in the intersection points with beams. These are on the top of the columns, and these are at the bottom of the columns. And important thing here is that you see this column is 400 by 400, and this column is 600 by 400. But column shoes are inserted to the corners of the column here and to the columns of the column here. So the reason is that after I click on insert command, our solution reads parameters from the host family from the column. It reads, let's say, B and H values from the column and writes these values to my family. So it's 600 and 400. This is the distance between the balls in my family. So when I create the family, I just give the name for this parameter to be the same name as the column parameter, and I group it under the model properties. So if I will do this, my insert elements software will read parameters from the column and write to the connection family, and with one click you can insert details to different sizes of elements. Let's say if I have two different sizes of these structural framing, double T slabs, and if I will insert the elements again with, I have this kind of a detail here, and I will insert them according, let's say, to the fixed maximum distance. Okay, I will maybe choose some different options here. Okay. option. I will insert 12 details. No, something didn't work. Oh, I forgot to switch off this option. Okay, so that's why I didn't have the result. First of all, sorry about that, but now you see the result. So I have one width of the beam, and now I have different width of the beam. Okay, so but these details anyway are inserted to the edges, because as I said, in the family I have defined this parameter, which is equal to the width of my structural frame. Okay. So other ways how to use insert elements is like you can use it in very different ways. Like if I will select these beams and I will insert elements, let's say here, and I will select different connection, you know, like a vertical hole just at the ends of my beam. So these elements are inserted here. Now you have holes in the ends, and if I will select to insert, let's say holes, I can search for the connected framing elements here. Let's say I select the type of my hollow slabs, and if I will click on insert, okay, now you see I have inserted these holes and the ends at the beginning, and now I have these holes for anchoring at the points of my anchoring points. Yeah, so these also families are adaptive according to the height of the beam, because if I had the same again command here, and I will use to insert the same vertical holes, the height of these holes are also taken from the host element, from the beam, so they are always cut through the full height of my beam. And the same with the horizontal hole. I can also use, let's say, for these kind of framing elements here, I will use such family, and I will distribute them the maximum distance. Let's say 2000 here, 2000 here, and this time there is no other family selected here, so it should be okay. Yeah, and now I have like cuts on the edges of my hollow slabs for anchoring again, you know. Okay, for columns, one more thing. Let's do it like this. I will select columns, I will select again structural connection. These families you can create easily by yourself. It's really not so difficult, just you have to think where it should be and so on. So let's say I will insert this anchor bolt at the connection with the beams, and the height of the anchor is taken according to the distance of the corbel. So now you see I have these anchor bolts here and here and so on. So you can easily insert at least most of the elements according to the rules. You don't need to, you know, place on the face, then move them right back and so on, switch between views and do it manually. Okay, so insert elements do this good things for structural engineers, but it doesn't work with walls, you know. And if you work with precast walls with sandwich walls or so on. You can't use insert elements. There are no rules for this. It doesn't work with walls. That's why we have developed new solution, Smart Details. So for this I will switch to next project, and Smart Details, next our solution to insert elements. Okay, I'll find it here. And again, on the dock you will see a few sections for configurations, for the create these details, to insert them, update, modify them, and so on, to delete them, delete selected, and insert gravity points and other functionalities you can find here. But Smart Details works like this. You have one main element and you insert details to it, so you can get something like this. So you insert different families like cuts or details or line-based or point-based elements. So I will quickly run through this. I will open configuration window. So you prepare configurations to insert details, how to insert and where to insert. Categories which may be used with Smart Details are walls, parts, structural framing elements, and line-based generic model elements. And you can insert line-based elements, so it's just a generic family of Revit, line-based, and face-based elements, so it's point-based elements insertion rules. And categories which can be used for the details is a generic model, structural connections, and structural framing elements. So here it works like this. You see these pictures. So three top are for line-based elements and then point-based elements. So on the side surfaces you can define, let's say, what kind of element, what kind of family you want to use. Then you just check the mark to insert this detail. You have 4 tabs here to insert 4 different line-based elements on the surfaces, and you choose on the face which one you want to insert elements. Then again you have some start, end of sets. You have a picture here to explain this is the face of the wall or structural framing or whatever. And you choose the layout direction, layout rule, and in one direction and the other direction. And here you can set up also to search for the solid of the wall available, and so on. So I will demonstrate this. Okay, so you set up configurations. You can set up as many details as you want. You see these green lights means that there are some details inserted here, defined. Okay, so I have here some configurations prepared, and now I will switch, let's say, to level 1, and I will use this on my walls. So my walls are just a simple regular Revit walls with 3 layers of different materials. Materials must be with physical properties. If we want to have gravity points, if we want to insert gravity point, you have to have density of all your elements. So it applies to your wall or to your details. So they have to have density. Okay. All the materials are assigned, just a simple 3 layers walls, and I have disjoint the ends of these walls, and on the corners I have situation like this because I use just a system of connections like this. So I will show you why is it selected some in this way. So let's say I will select 2 walls, and I have configurations already, so I will use command to insert details. And I just pick the configuration I want to use. And I will click on insert. So now the tool inserts all the cuts and all my details into these elements. Okay, so maybe, okay, I will show you what happened in the plan view. I have here vertical cut inserted. I have tubes at the bottom inserted. I have these connection loops inserted here. So you see it was inserted on this face according to the cut made. And if I will switch to the section view, you will see that I have also inserted here fillet. I have inserted here horizontal cut for slab support. Yeah, and I have some additional architectural like cuts on the face of the precast wall. So it's just to see the possibilities. Okay, I will go also to the transparent version. And you see now that I have these tubes defined by the rule of a maximum distance, and I don't have a tube here because in this, if I will click modify here, I have here a possibility to search vertical faces and to search the minimal solid depth. So if I have a window, my detail will not be inserted. So you can use smart details, and of course you can use some additional details which you can insert manually. The same workflow which manual could be applied also. Okay, and now I would like to finish maybe this part, so I will do the same so we can see the picture of. I apply the same configuration for this panel also, even if this panel is shorter than this one, because we can use different rules, you know, and it may be used for different sizes of the panels. And details also may be prepared in such a way, like in certain elements we can take parameters from host elements. Okay, I select this one and this configuration. So now different cut on this side will be made and some additional reveals. This reveal was added, and I have let's say here I have such kind of a void cut on the corner, and I will do the same here, but I will use again different configuration. So I have, let's say, this configuration, and again I can prepare what kind of details I want to insert on which surface, like I have inserted here on this surface, on the side surface, connection loops, and so on. So I have this pretty good picture and modeling here. Okay, so I can just do the same with all my elements. Of course I can use different configurations, different details, and so on. If I will select, let's say, this one, I can use different configuration, let's say a massive wall plates, so I can use plates, you know, different connection details for the bottom, and different okay, transparent view maybe, and for the top here, so I can just do the same with other panels. Okay, so yeah, so that's how we model elements, that's how we insert elements in Revit with our add-ons, with insert elements and smart details. Now I will switch to the next solution. So we have solution for the walls, for the floors. So you see some floors already modeled here. If I will go maybe to the 3D view, you see I have floors modeled in few of the floor levels. But so I will show you how to do this on the. I will switch to the fifth level, and we have solution which is called smart floors. So again, we have here different commands, but I will show some of them. How does it work? I will just click on insert update floors, and now I have this dialog where I need to enter the group name. I have to select support for my floors. The reason for this is like to have possibility to update these elements and to follow the changes in your project, so they might update according to the if I will move the beam or any other boundary of my floors. So I select the boundaries, beams and wall, and I enter here offset value to make it on top of a beam. I enter here the width of my panels, and I assign parameters to be written to these, and they may be used in schedules. So for the precast floor type, I will use just a regular Revit floor, not framing elements as we do sometimes for modeling of hollow slabs, but we use these floor elements, and we insert holes into the floor elements. So we select the sizes of these. We have some holes configurations most commonly used, and now we have layout length, which is taken according to the boundary elements, and we have like 20 panels by 1200 millimeters width. So we have this length, but we still missing 500 millimeters. So we can just insert, cast in place, just a massive slab for this option. And we choose the level of the height offset, and we click on insert. Okay, and you will see that we have now floors on the 5th level, and if I will go to the section view, you see now that this is the 500 millimeter width floor, massive floor, and now here we have hollow slabs and holes inserted here, and all of the slabs have now been modeled, and they are smart, so they are possible to update anytime or modify them, split them, insert additional holes if we need to do this for some kind of massive slab. And maybe once more I will do the same. I will give a different name, but oh sorry, okay, I will give a name, and I will choose this time beam with an angle. I will choose layout beginning as a beam and layout end as a grid line, and I will enter here offsets again. I will choose the same size of my slabs and the same size of my holes, and I will click on insert. Now I have these slabs, but as I said, they are smart, and if I will select them again and I will click again on insert update floors, I will have the same configuration window for this for my slabs, and I can, let's say, change the layout beginning boundary, and I will click on update, and I will have these floors, let's say, between these two grid lines. So I can use also reference planes and grid lines and beams and walls as boundaries for my floor elements. And yeah, it should look like this. So now my as I have modeled a lot of elements in my project, and I want to write different mark numbers to them. You know, you can do this just manually by clicking column and going here, or you can prepare some schedule tables for structural column, let's say, make some filtering of them, and then make markings, adding marks. But we have better solution for this. We have solution which is called sort mark. So here it is. If I will select this, you see here some options like to renumber grids, renumber elements, or other things which are in the project. So for this reason, I will select element numbering, and yeah, now I can select from the categories which are available in this project, you know. So let's say I have created these new floors and I want to add numbers to them. So I will select floors and I will click OK, and I will write values to the mark parameter, or I can just create new shared parameter over here. And now again, I have a lot of possible rules to apply here. I can select from a lot of parameters and select how to group elements, how to number them, how to sort them according to which parameters, you know. And I can save this configuration and I can use it in my future project. So, and on the sort mark tab, I can select what information should be written to the mark value. You know, let's say I want to write the number of my level. So first of all, I will add HC as prefix, then I will write this value number from the level name, and I will have suffix, and then I can insert sort mark number, which is according to my sorting rules. So I save this configuration and I click OK, and all of my elements are renumbered now. Some of the elements have, of course, the same mark values because they have the same parameters which I have defined. And if I will go to this, let's say, slab plan, and I can just let's insert some tag numbers to be selected. Let's choose the mark and vertical, and OK. So you see now I have all these elements automatically renumbered. If I will go to the, let's say, to this view, you can see question marks here. These are for my beams. So my beams are also, they don't have the mark value currently, but if I will choose element numbering again with sort mark, and I will go to the structural framing category, I will write it to the mark values. Again, I have configuration already prepared with different options, and I'll click OK, and all of my elements have mark values now. So you can see now that all of these elements have different marks according to the, of course, the sizes, the length, the width, the volume parameters. It depends on the parameters I select, any available from the instance or type parameters. Okay, so I would like to do the same with the columns, because I will need them to show you how smart assemblies work. So I will do this once again with structural columns. I will write values to mark, again configuration for columns, and I'll click OK. So all of my columns has been remarked. They have now different mark values. Okay, so this is very good solution, to keep the standards of the company and quickly renumber elements. Okay, so the next solution, after we make the modeling, we make the mark values, we need to prepare some drawings. So for this I will use solution Smart Assemblies. And okay, here are two sections in Smart Assemblies: to create, update, edit configurations, and so on. And of course this is done according to configurations, as in most of our solutions. So I will open configurate. Oh, sorry, this is the location of configuration files. So it's actually, it means that configurations are saved to your computer. They are not dependent on the project, so you can use the same configurations in next projects and so on. So okay, I will open configuration window, and here in configuration window you can see now assembly views tab. So here you can create as many views as you want for the element to create. Then you create the view type. So will it be the section, will it be the elevation views, or it will be the legend. And you see some additional views, like in standard Revit you have only the section to one direction, but we have some additional views, so they are flipped already, and it solves some issues which you might have while using standard Revit. And of course you from the beginning you can choose the direction of your view. Okay, so you can give any name to this view. I just leave the standard name, but you can write anything in your language, or just give any view name. And we can assign view template, any of the view templates we have in our project for each of the views, so it will be done automatically. You don't need to go and do this manually. And then the last option is dimension rules. So dimension rules are set up over here. If I will open it, you will see that we have again dimension rules, different dimension rules here, and these are for placing automatic dimension to your elements. So on the first tab you can see the rules for the main element geometry. We have here dimension types. We can select the which holes should be dimensioned or they should not be dimensioned, how lines should be joined or disjoint, or the separate dimension lines should be created. So we make our adjustments here. You can see also these pictures and follow what are you doing. And here set up to split dimension lines, or have this quotation formula here. And then we can we have these configurations of dimensions for hosted metal details, for hosted concrete details, for the rebars, for the at the end we have possibility to switch off or switch on the nodes which will be created, and what kind of information should be provided to the node. Yeah, and again, a possibility to place the nodes on each side, or to just connect detail lines and so on. So you can prepare different configurations and use them here, and you can tag elements in views. You can show gravity point in views. So I just chose to show it only on front view, and to show or not to show the place of the views of a section. And we have here some special options below to insert gravity point or not to insert, to orient element to the family editor front view. And for the walls there is a special button, because you may have reversed sections while using standard Revit cuts, so this may solve some options. And the next tab is schedules, so you can select again schedules. You can select what templates could be applied for schedules, so you don't need to do this manually, and select if this will be for the assembly instance or assembly type, the amount schedule values. And the sheets, here you can use the sheet as a template, but first of all you have to create at least one assembly drawing. So for this now, okay, let's go to the action. So I will select one of the columns and I will create assemblies. And column formwork configuration, and I will click on create. Okay, so views are created, dimensions are placed, and schedules created also. Okay, now I have this column. I have views with automatic dimensions, with nodes, with total dimensions and so on. So I can go on. I see that the gravity point is presented in the front view as I was selected, and I have the place of my section views also visible in this view, but not in any other views. Okay, so I will, let's say, drag some views to my sheet. Okay, maybe not this one, but the left view. You see the blue line appears for the alignment of the views. Okay, column schedule and hosted details schedule. So I place all the views here, and now if I will change the configurations, and on the sheet tab, as I said, after I create one of the sheet, after I place the views, I can use this sheet as a template for other columns. Let's say I have this column, and I can now create assembly, and let's use the same configurations, but now all the views will be placed on the sheet. As I did here manually, now it will be done automatically. So let's wait a few seconds, and let's go to the sheet now, and you see now the new column created, the sheets are placed, and we have of course dimensions to this new hosted detail, and so on. So the views are in the same place, the schedule tables are placed. You can have also legends here, and so on. So this helps us a lot to make our drawing, so you can use it for different elements. Like if I will select the beam and I will select the configuration for the beam. Okay, so you may have different views, you may have different amount of views, different amount of schedules, different amount of sheets for each of the elements. And yeah, now we can just run through. We can see the results. Okay, so all the dimensions are placed. Maybe one more. Let's say we create assembly for this element. But I would like to notice also one thing which is also saves us time. So I select only one element. I don't select all the details. Smart Assemblies does this automatically. It includes all the hosted elements, and these details are automatically included into my assembly, so I don't need this to do this manually. Okay, I can just overview. I can place these views to my sheet and use sheet as a template. Okay, let's do this with another beam, just to show you how different elements could be created. Okay, and let's see, where is it? It's, okay, now I have this element, you know, with dimensions for holes, with dimensions for the horizontal holes, and what's next? Okay, so smart assemblies with columns, walls, and other elements. And in the other project, maybe I will show you the results with the wall. I can just select the wall and create assemblies, and again I select one element, and all of other elements are automatically included into my workshop drawings. At least at formal drawings for this element, because I don't have reinforcement elements here, but you can see now the wall views. Maybe I can just drag these over here. Okay, and some schedule tables too. Okay, and I have all the schedules prepared automatically. I have the element mass and so on. Yeah, with all the details dimensioned in different views. I can select where I want to see them. And the sandwich, okay, I have already the sandwich panel created here before. Oh, I missed the sheet boundaries, as I see, as I placed these views. Okay, anyway, you can use these for this kind of details also, to get at least a major part of your work. Okay, so yeah, I think that's it, and all I wanted to say today. Yeah, I will switch on now questions, and I will answer them if you have any of questions. If this webinar is recorded, yes, it is recorded, and it will be placed on the web, and yeah, we can show you record, and we can send you the link.
Länken till webbinariet kommer finnas även på vår hemsida. Och att det kommer att gå ut i ett mejl till er som har deltagit också. I think that the link will send out in a mail from us to the webinar. Allt ni har sett här nu på betongelementen går ju även att applicera på en träväggelstomme. Några fler frågor så bara skriv på. Is there any more questions, Ansas?
Oh, I see the question about reinforcement. So to insert reinforcement, you have to do it manually with your just Revit commands or Revit extension maybe. But in workshop drawings you can use configurations to dimension your reinforcement. Sorry, I don't have this example, but actually in the configurations of smart assemblies you can define all of these to show only reinforcement and to dimension reinforcement. But reinforcement you have to create on your own. We don't have tools for that.
Okay, if there's no more questions, we will thank you all for attending the webinar, and thank you, Vanessa, for showing us the products that the AEC developed.
Okay, so thank you for joining me. And yeah, try these tools. You can download the tools for BIM doc, and you can have trial of 14 days of any of our tools. So please do this, and if you have any questions you can always write to support of AEC, and we will answer any questions you have. So that's it, I think, right? There are no questions, and we will end.
Well, thank you.
Okay, thanks. Bye bye.